Okay, when I estimate, you get to choose how you estimate, which means you get to choose how you round. So when I'm looking at 245 plus 389, what could I round 245 to and 389 to make them easier so that it's easier to solve for an estimated sum? What would you maybe round these to? Yes. 250?
390.
Okay, so think for just a minute. If I did 250 and 390, looking at these numbers, is that easier to work with than what I have originally? Yeah, because in the last place, I have a 0, 9, and 5. I know that makes what? 14, and then I would carry that extra 1 up there, and so I have 640. So my estimated answer would be about 640. Okay, over here, I have bigger numbers, but I'm subtracting this time, so I want to make sure I'm focusing on the operation. Okay, looking at 9,882, what could I make these numbers into be to make it really easy to solve? Jeb, what would you do 9,882?
9,880.
Okay, I could do 9,880. That would work. Could I make it even easier? Austin?
10,000.
I could do 10,000. That's what I want to do because I've got big numbers and I don't want to I want to be able to try and do it quickly, maybe even in my head. So I'm going to make them as easy as possible. Okay, so if I rounded 9,882 to the nearest 1,000 or 10,000, what would I round 7,647 to? Jason?
7,600.
So I rounded the first one to the nearest thousands place. So I want to do the same thing for this one. I want to round them the same way. If I round one to the thousands, I don't want to round the other one to the hundreds. I'd also want to round it to the thousands too. So if I do that, what would it round to? 8,000. And now is this a lot easier to do? Yeah, 10 minus 8 is 2. Since I'm dealing with thousands, it's about 2,000. Okay. Okay, now looking ahead, the only difference between those numbers and these numbers is that these numbers are decimals. So again, just like our bell ringer, I told you, think about money. Anytime we're working with decimals, I like to tell my students to think about money because that's something easy for us to picture, and it's something that we work with every single day. So looking at the very first one, I have $2, imagine, okay, there's no dollar sign. $2.45. Is that closer to $2, $2.50, or $3? Riker. 250. That's an easy number to work with. So I'm just going to do 2.5. And then 3 and 89 hundredths. Would that be closer to 3, 3.5, or 4? Lyndon?
4.
Okay, now, do you notice what I just offered? The options that I offered. I offered to the nearest 10th only with one digit, right? I said 3.5. I also offered to the nearest whole. But notice how I wrote this. Oh, where is my pointer at? Is this it? Okay. Sorry, they changed the look of my screen, so everything looks different. All right, so notice how I have one digit right here. What if, because yes, this is close to 4, but what if I want to round this number to where I have one digit after the decimal? What would be the closest 10th? If I want to round it to the nearest 10th, what would I round it to?
9.
Yep, I would do 3.9. So it makes it a little bit easier to round it if I round to the same place. I got to pick a place that I want to round to, make them easy. Okay, so now 9 and 5 together makes 14, and then that's going to become 6. So 6 and 4/10. Now, I could also round to the nearest whole if I wanted to. I could round this number here all the way down to 2. And I could round this number up to 4, and it would be about 6. But looking at both of these answers, they're both pretty close, right? This one's just a little closer estimate. All right. Moving over here, I'm going to let you try this one with your table. Talk about what you want to round each number to. Round them first and then solve it. We don't ever want to solve it and then round our answer. We want to round first to make it easier on ourselves, then solve it. Okay, so what did we decide in our groups to round 98 and 82 hundredths to? 100, I love it. Yeah, 100's easy. Okay, well, if I rounded that one to the nearest whole number, I should probably also round the other one to 80. I love that. I like it better than 76. Okay, so if I'm rounding the tens digit, I've bumped it up to 180. That makes it easy to solve, which is 20. Okay, so let's move into our lesson. All right, looking at the top on the next page, it says you can use rounding or what we call compatible numbers to estimate sums and differences of decimals. You will use an estimate when you do not need a precise or exact amount. So rounding is what we just used. Compatible numbers is another thing I really, really like. And I really like it whenever we're dividing because it makes it easier to choose numbers to divide by when you get into bigger divisors. That outside number, if you look at my chart over here, the divisor is the purple 12 on the outside of the division box. It makes it easier to identify compatible numbers. What does that mean? Compatible numbers are numbers that work really, really well together. If you think about people being compatible, you're like, oh, they go really well together. Okay, compatible just means they go well together. So numbers that are compatible work really well together. Okay, we're gonna jump down to our practice here. It says estimate the sum or difference. We're gonna do 1 and 2 together. I'm gonna let you guys try with your groups a couple of the others. Okay. Number 1, I have 112 and 18 hundredths that I'm adding to 47 and 99 hundredths. Okay, I'm going to round these to the nearest whole or the nearest ones digit. So I have 112. What would I round that one to?
110.
I'm going to use this as my judge.
You wouldn't round at all.
It'll stay 112. And then 47 and 99 hundredths will round to 48. Okay, now looking at this, this is what I consider compatible. Why would these be compatible? Why do you think 112 and 48 are compatible?
Because one has 3 numbers and the other one has 2.
Okay. What specifically about the numbers do you notice? Caden.
12 can go into 48.
Ooh, that's interesting. I didn't notice that. It can. Doesn't help me with adding, but that is a fun fact about that. Yes. What about adding? What do you notice that's really easy with these two numbers? Look at the ones column, the last place that you would add first. London, what do you notice?
You add 2 and 8 together.
2 and 8. And what does 2 and 8 make?
10.
10. Yeah. So it's a number that's going to end in a 0. And then this, if I carry that 1, will become a 6, and that's 1. So 160. Okay, on the next one, I'm going to round these to the nearest whole number. I'm going to do, actually, yeah, I'll do whole number. So if I'm doing whole number, 68 and 8 tenths will round up to 69. The other one would round to
20, 30.
30. And then I can subtract that easily to make 39. Okay. On number 3, to use rounding, I want you, just make a little note. I'm going to have you underline the place that you're going to round. Okay. On number 3, I want you to round to the nearest whole number. So underline your whole numbers. On number 4, you're going to round to the nearest whole number. So underline the ones digit. On number 5, y'all are going to round to, I think I'm going to have you round, well, I'll just let you choose. I'll let you choose on 5 and 6. Okay? All right, go ahead and work these with your table. Take about 2 minutes, and then we'll check. Okay, looking at number 3, I have 7 and 95 hundredths. I'm going to round that to 8. And then I'm subtracting what?
2.
2. So my estimated answer should be
6.
6. Okay, on the next one, same thing. I'm going to round to the nearest whole number, so the ones digit. So this is going to be 238 plus 345. Okay, whenever I add that together, you should end up with what? 583. Great job. Okay, somebody from Peach back here, boy table. Okay, somebody tell me what y'all chose to do on number 5. How did y'all round?
Same thing.
Yeah.
We did the same thing.
Did the same thing?
Yeah.
So we did 68
Yeah.
minus 15,
Ooh.
and you guys got what?
What'd you get? Oh, I did
50 what?
I did 80 on 67.
Why not 70?
I mean no, I meant to do 7. I meant to say
Okay,
70.
I like that. Okay, so we did
I got
70
85.
minus 15 to get 55. You're subtracting, not adding.
70 minus 15.
All right, so here's what I like about these numbers that this Peach table picked, because they were like, well, actually, we didn't round to the whole number. We just bumped 67 and a half up to 70 and subtracted 15. Why do I like these numbers? Why do you think? Raise your hand.
Because
Jeff.
they're easier.
They're easier. One ends in a 0, one ends in a 5. These are what we call compatible numbers. Good. Okay, number 6 on this one, I might round 418 and 98 hundredths to what? What blue table? Somebody back here tell me what numbers y'all picked to use on this one. Claire, go ahead. Hold on, number 6. Over here. Number 6. Not down here. Oh, the digits. You're telling me the digits that you rounded. Okay, I thought you were going to tell me the numbers that you got. Okay, so what numbers did you get? Like, what did you actually add together? Yeah.
419 and 15.
419 plus 15. So if they did 419 plus 15, then they would have ended up with 434. Okay. Anybody choose a different way? What did you pick?
We rounded one rounded to the 100 and then the whole. So we did 400 plus 15.
So we did 400 plus 15 to get
450.
415. Okay. I like it. Anybody do something different?
Yeah, I did.
What did we do?
I went down to 415 and then on 14 I rounded it up to 15.
I like that because, again, I have compatible numbers here. 15 and 15 makes 30, so that would be 430. There's 3 different ways. So what are you learning? What are you understanding about estimating? Is there a more right way to do it? Not necessarily. It's kind of how your brain thinks. It's what your brain thinks is easier to use. Okay, there's 3 different ways that we just showed how to add the same decimal numbers using estimation. Okay, what I would have done, I probably would have done 418 up to 420 because it's really close to 420, and then I would have added it to 15, so that's 435. That's how I would have done it. It's still compatible, just like 415. Okay, how you see numbers, how you manipulate numbers is going to be a little different than how your neighbor might do it or how I might do it. Okay, let's look at number 7. On number 7, I'm going to do 14 plus 8, which is 22. And then on the next one, I might do 210 minus 60 would be easier. And if I do that, then I'm left with 150. Okay, moving on to the next page. Here I have an example question of what you might see on a test. Select all the expressions that have an estimated sum of 140 when each addend is rounded to the nearest 10. First of all, what is an addend? Yes, Jeb?
The number that you add.
Yep, they're the numbers that you're adding together. So these are all add-ins here, all of these. Okay, so which expression, and there may be more than one, have an estimated sum of 140. Let's look at A. If I round A to estimate it, this would be about maybe 84 plus 60. Okay, that would be, if I'm adding them together, what do I end up with? 144, right?
Oh.
Well, what if I just made this 80? What if I rounded to the nearest 10 and I did 80 plus 60? Would that be 140?
Yeah.
Yeah, so this one can work. Now this one, if I round this one, to the nearest 10, it tells me to the nearest 10. If I round this one to the nearest 10, I'm going to underline my tens digit. So 106 rounded to the nearest 10 is going to be 110 plus, this would be 40. This equals 150. So that is not going to work. This one rounded to the nearest 10 is going to stay 130 plus this rounded to the nearest 10. There's a 0 there. That would just be 0. That's 130. That one won't work. And then I have one more. Underline your tens digit. 7, but my judge is a 3, so this is going to be a 70 plus, what's 67 going to change to? 70, and 70 plus 70 equals 140. So I have two answers on number 9. I have A and I also have D. Okay, number 10. I want you to match these with your tables. So match each sum with its estimate when each addend is rounded to the nearest whole number this time. So you're rounding all of them to the nearest whole number.
So no, that was not. 28, so that's all
Class O, class. Class O, class. Thank you. Okay, the very first one, looking at how these should be rounded, the pink one is going to end up being 27, so that should be going to the third helicopter. The orange one is going to be 28, which is the last one. The other pink one is going to be 12 plus 14, which is 26. It's the second helicopter, and the purple one goes with the first one. All right, next, match each difference. Same thing, I'm going to round to the nearest whole number again, but this time I'm subtracting. So this is going to be 82 minus 56. The orange will be 56 minus 28. You're rounding to the nearest whole number again, so you're looking at the ones digit. Okay, the pink one will be 50 minus 25, and the purple will be 45 minus 18. Draw your lines accordingly. The third one's probably the easiest because those numbers are compatible. They work really well together. I know this is 25. What would that peach one in the very front, what would that match up to?
26.
26. The orange one would match up to 28. And then the purple goes to 27. All right. We're going to skip. That puzzle one is fun, but we'll come back to that. So we're going to skip 12 and 13 for now. We're going to go on and look at this chart with a word problem. Okay, we are given a table, and it says the tallest buildings in New York City in feet. It says about how many feet taller is One World Trade Center than 1 Vanderbilt. So when I am looking at how many feet taller, this is a good keyword for what operation? Adding or subtracting? Subtracting. Okay, so I want to identify 1 World Trade Center, this number, and 1 Vanderbilt, this number, and I'm going to subtract the 2. And again, your key word here is about. That means I'm estimating. So I don't want to know the exact amount. I want to round. So I'm going to do 1776. We could probably round that to what? 1
to 800.
780.
You could do 1780 if you want to. Round it to the tens digit. Fine with me. So we could do 1780 minus, what would 1 Vanderbilt round to if I round to the tens digit? 1400. And that's easy to solve now. I just have 380. It's about 380 feet taller. The next question says, is it a reasonable estimate? Reasonable estimate means, first of all, we know what estimate means. It's a rounded answer. But reasonable means, does it make sense? Like, is it my best option? Okay, reasonable, does it even make sense? So is it a reasonable estimate that Central Park Tower is about 120 feet taller than the other one? So if I rounded it, and I said 1550 minus 1430, that would be about 120. So yes, that is a reasonable estimate. And then the last one says, which has an estimated total closest to 3,000? The combined heights of 1 World Trade Center and 1 Vanderbilt, or the combined heights of Central Park Tower and 111 West 57th Street. So if I'm adding these, now earlier I subtracted with these, but these are the 2 that I'm using again. So if I add these 2 numbers together, because the word combined means I'm adding, okay? So I would do 1780 plus 1400, and that's going to be 3180. And then I have the other 2 that I subtracted a little bit ago here, these 2 numbers. If I do 1550 plus 1430, that's 2980. Now, here's where I get stuck. I got to figure out which one is closer to 3,000. So yeah, if I'm looking at the first one with the World Trade Center, this is 180 away from 3,000. This is only how many? 20 away. So it's going to be the combined heights of Central Park Tower and 111 West 57th. I'm just abbreviating to fit it in there. Okay, we're going to do a little bit of plickers practice.